at linear functions to begin with. Okay, but first we need to think about what a function is. Okay, we need to talk about what a function is. So I'm going to draw something very quickly just on the side. All right, just on the side. I'm going to take you guys back to grade 4, grade 3, grade 4. We used to have things called spider diagrams. Who remembers what a spider diagram is? You guys remember? Spider diagrams. Just to show you that maths is interconnected everywhere that you do it in whatever grade. We used to have this thing, 1, 2, 3, 4, and then there'd be a block here. And in the block, there'd be like a ×3, and then there'd be an arrow, and then it would go +2, and then there must be like something coming out on this side. Right. Now, we used to have these kinds of things when we were still in school, right? And in grade 2 and grade 3, we used to do this. We used to put a 5 here, and then we would put a 1 here, and then we'd put a 7 here, and then you would have to feed these in, and on the other side, they would have to give you a number. And then over here, I would put an 11 over here. I put an 11 over here, and over here, I'd put a 32. So I would then have to figure out 5 times 3 is 15, plus 2 is 17. So I would end up with 17 on this side. And for 1, I would go 1 times 3 is 3 plus 2 is 5. And then for 7, I'd go 7 times 3 plus 2, that's 23. Right. But now for these numbers over here, for these 2 numbers over here, I would have to work my way backwards because they're saying what times 3 plus 2 is equal to 5, is equal to 11, and what times 3 plus 2 is equal to 32. Now, if we do a little backwards thinking, we could go 32 minus 2. Exactly, that's it, Nolazi. We would reverse. We would minus n and then divide, right? So 32 minus 2 would give me 30. Divided by 3 would give us 10. So we know that this number over here would be 10. And then over here would go 11 minus 2 is 9. Divided by 3 is 3. And that's how we would do this, okay? Now, this is essentially what a linear function is. We have an input. We put in a number, and then we do something. The machine does the what you may call jabba in the middle, and then we have an output come out here, right? Now, if I had to represent this linearly, I would say that my y value, my output, is determined when I take my x value, my input, and I multiply it by 3, and I add 2. That is what the spider diagram is actually telling me. It's telling me that if I put something in on the one side, I'm going to get something out on the other side. So if x is equal to 5, then y is going to equal to 17. This is what linear or all functions really are doing. Okay. Okay. That's it. So we're doing Mawande, that's it. We're literally doing a spider diagram, but with algebra. That's exactly what we're doing here. Okay. Today's topic, Amuhelang, is functions. All right. So just like what I've done over here, I have given you guys a function. I've given you a function. And we know that if we put in some value of x, a y value will come out. So I'm going to ask you guys, if my x is equal to 0, what is my y going to be? Then y will equal what? If I go into this formula and I replace x with 0, what will my y value be? Gabriel, you rock star. Mawande, excellent. Okay, so I'm going to get 2 times 0, which is 0, plus 1, which is 1. And then I'm going to ask you guys to do the same with 1. If x is equal to 1, then y is equal to what? Sure, Gabriel is fast. Just. I feel like Gabriel has the answer written down and Gabriel's waiting for me to ask the question and then just clicking enter once. Then y is equal to 3. Excellent. But what if x is equal to -1? Ah, I knew it. Gabriel, I didn't even finish asking my question, and Gabriel already put the answer in the chat. I see you. I see you. If x is equal to what? -1, then y is also equal to -1. Now, when we look at these things, and as we've learned from analytical geometry and from grade 9, when we look at the value for x in relation to the value for y, we call these two things ordered pairs. They are ordered pairs. Okay, they are ordered pairs. For every x value, if my x value for this function that we have, if my x value is 0, my y value is 1. So I can then write them like this, 0 and 1. That's my x value. And for my y value, for my x value, when x is 1, I'm going to get, if x is 1, y is 3. That's how we put it in there. And if x is -1, then y is -1. And that's where we get the idea of coordinates. We are looking at what one is in relation to another. Okay, so I'm going to put these ordered pairs over here because we're going to look at them again. Right, 1 and 3. -1 and -1. Okay, I want to show you guys that these ordered pairs that we're actually talking about do not differ whether we make the thing 1 or whether we make it a function. Now, let's look at this f of x. And I bet you, give me a thumbs up if your teacher somewhere while learning functions has said to you, f of x is equal to something. Has your teacher ever said the word f of x? Give me a thumbs up if you've heard of this. Okay, this over here is f of x. F of x. It's f of x. And what f of x actually means is we are looking at the function in relation to x. Okay. In relation to x. Princess, look at that. I'm just there, exactly where your teachers need to be. Right. We're looking at the function in relation to x. So what this is actually saying is, whatever x is over here, I'm going to replace that with x over here. And we can do this exact same thing that we've done again, except we're going to write it a little bit differently. We can then say, if I ask you guys, what is f when x is equal to 1? F of 1. What would f of 1 be? We would then go into this function. Because I've replaced x with 1 over here, anywhere in my function where I see the number or the letter x, I'm going to replace it with 1. So I can go f of 1 is equal to 2 times 1 plus 1, which is equal to 3. So that means the function of the function at 1 is equal to 3. Right. If I said I wanted f of 2, what would my answer then be? If I wanted f of 2, that means I want the function at the x value of 2. And my answer, yes, Moteo, 100%, Daniela, that's it. The answer would be 5. So f of 2 is equal to 5. Now, when we represent these things, we want to see what kind of relationship they have, right? Is it an increasing graph, a constantly increasing graph? Is it a decreasing graph? What is going on? Right, we're going to use the Cartesian plane. We're going to use the Cartesian plane. So if any of you remember, let me just see, raise your hand if you were taught by teacher Jen last year. Anybody taught by teacher Jen in grade 9? I'm just, Mateo and Shaden. Okay, if you don't know who teacher Jen is, she was our wonderful, most fantastical grade 9 teacher. And for those of you who still seem a little bit lost, it's not the end of the world. It's not the end of the world. Okay. Okay. Teacher Jen actually did this very, very brilliantly. She explained to you guys how to find all of these values, okay, using the numbers that we've got here. No worries, other Tsiamo or original Tsiamo. Michael, she has a very important job now. Okay, I'm sorry about that. Okay, she just, I don't think, because she works for a company that's, their hours are a little bit different. Okay, so she works at, right now, she's at work. So she couldn't possibly be in 2 places at once. Okay, cool. So we're going to do that. So don't stress. Don't stress. It's not as complicated as it seems. Okay, if I say to you that I want f of 3, that is equal to, I'm going to go here. Okay, I'm going to go here where I see x, and I'm going to replace it with the number 3. So I'm going to get 2 times 3 plus 1, which will then equal to 7. Okay, Shaden, do this along with me. Do it along with me. I've got f of x. I've got f of x is equal to 2x plus 1. You see it? F of x is equal to 2x plus 1. We're going to take the letter here, this x over here, and we're going to replace it with a number. But if we do it over here, we must always also do it on this side. So if I asked you, what is f of 5? We would then go 2 times 5 plus 1 is equal to, what's 2 times 5 plus 1? It's 11. Good, it's 11. Good, guys, it's 11. All right, I want you guys to, Khalala says 111. Okay. No worries, no worries, Mawande, we'll be right here. Good. Okay, no worries, Khalala. It's no stress. It's not a stress at all. I'm just making fun. That's fine. Okay, so we understand that the function, the f of x, just tells us what we're going to replace x with. That's all. Right, now guys, if we look at our Cartesian plane, remember this x and y axis that we're very familiar with from grade 9 is called a Cartesian plane. It's called a Cartesian plane. We want to use this to draw something that we want to draw the function. Yes, absolutely, Shaden. You get to choose which number x is. Okay. Hello, I'm Kelisiwe. You get to choose the number. You can think of a number and you can replace it there. Right, remember guys, this is called the Cartesian plane. Okay, the Cartesian plane. Now, if we look at our ordered pairs, on my x-axis, this is all my positive x numbers. On this side, this is 0, guys. This is at 0. And over here, I'm going to get all my negative x values. Up here, I'm going to get all my positive y values. And down here, I'm going to get my negative y values. All right. So I need you guys to remember that this value over here is x, and this value over here is y. All right. Yay, my wonder, welcome back. Okay. So when x is equal to 0, I know that 0 is over here. Y is going to be equal to 1, but 1 is positive. So I'm going to put it up here. Okay, I'm going to say this is 1. Right. So my first value is going to be at 0 and 1. Right. I'm going to ask you guys in terms of this next one. This is x and y. If my x value is 1, and I'm going to put it over here, what is my y value? If my x value is 1, what is my y value going to be? Tinyiko, it's right there in the answer that I gave you. X value is 1, y value is 3. Good, it's 3. So I'm going to go up to the positive side of y. Remember, we need to go to the positive side. I'm going to go 1, 2, 3. That's 3. But they need to meet at this point, so I can do that. Okay, that's okay, Makawanolo. We're going to get there. Just give it a second. Right, so that's the point where they meet at 1 and 3. Yeah, we're going to do it again. I'm going to explain again. I just need you guys to give me a second. Okay, I need you guys to give me a second. Right, hold on. If I had to look for x This is my x value. X is -1 and y is -1. I'm going to go to the negative x side of my x line, and I'm going to look for -1 over here. -1. And can I ask you guys, if I had to look for my y value, it's -1. Is it going to be above or is it going to be below the 0 line? Will -1 be above or below the 0 line? Below. Good. It's going to be below. Right. So my -1 will be somewhere over here. -1. And then I just need to make sure I see where they meet. I need to bring this one in and this one over. That's where they meet. That point over there is -1, -1. Okay, let's do that again. Let's try that again. Okay. We're going to try that again. Okay. Right. I need you guys to just follow with me. Any positive x value will sit here on this line over here. And any of my y or any of my x values, not just the positive ones, the negative ones will sit here and the positive ones will sit on the side of 0. For my y values, all my positive y values will sit up top here and all my negative y values will sit down here. Right. So let's go back to our function. Let's go back to our function. Our function says, okay, let's choose a different number, I think. Let's do this. If I make that's it, yes. After we plot the points, we join them and they give us a straight line. That's it, Sepang. Yes, yes. Asemache, we're going to do that in just a bit. All right. If I say that my x value is 1, guys, what is my f of 1? If I had to replace x with 1, what would my f of 1 be? Good, Nicole. Good. I'm just going to replace my x with 1. 2 times 1 plus 1 is equal to 3. So at the point x, if my x is equal to 1, my y value is equal to 3. Right. If I say to you guys that I want the function at x is equal to 2, if my x value is 2, what will my y value will be? Okay, Shaden says you don't understand how we get to 3. Look here, Shaden. If I replace this x with the number 1, I also have to replace this x with the number 1. Okay, what's 2 times 1? That's 2 plus 1 is 3. Okay, thank you, Simpiwe, that's it. Okay, does that make sense? Does that make sense, Shaden? I hope I haven't left you behind. Okay, so over here, where we've replaced x with 2, okay, if we replace x with 2, I'm going to go into this formula over here, and I'm going to go 2 times, replace x with 2 plus 1. And then we're going to go 2 times 2, which is 4, plus 1 is equal to 5. Eunice, F stands for function. It stands for the word function. Okay. So that means when my x value is 2, my y value is 5. Okay. Now, for those of you who are saying you're still a little bit confused. Okay, Khopotso says, why do we have 1 and 3 and not just 3? Because remember, Khopotso, this is our x value and this is our y value. Okay, I put 1 in for x and it gave me the answer 3. This is my input. My input was 1 and my output was 3. Okay, I put x into the formula and the answer I got out was 3. Okay, so now if I ask you guys, what would my answer be if my x was 3? If my input is 3, what would my output be? That's it, Motel, that's it. Yes, good. It would be 7 because we would go 2 times, replace x with 3 plus 1. And that would give us 2 times 3, which is 6, plus 1 is 7. So I first write my x value. I replaced my x value with 3, and the answer that I got out when I replaced x with 3 was 7. Okay, give me a thumbs up if you are with me. Give me a thumbs up, guys. Excellent, excellent. Okay, cool. All right, so that's what we're doing here. Okay, that's what we're doing here. We're making sure that whatever x value comes out, the y value also corresponds. Hi, Shaden.
Ma'am, I just want to say I'm frustrating myself because I'm really not getting it. I'm actually angry at myself because whenever you explain something new, I always get it. And I just don't know what's going on today. I really don't know what's going on.
All right, okay, wait right there for me, Miss. Okay, do you see this function that we've written over here, 2x plus 1? You see it?
Yes, and you said it means 2 times 1. I think 2 times 1 plus 1.
2 times x. 2 times x. Good.
X
so Shaden, we're gonna pick what the x value is. I want you to pick a number for me. Any number.
2. 5.
Good.
5. What?
Okay.
Okay, 2.
Let's
5.
choose 5. Are you okay? Are you okay with 5?
Yes, 5 is fine.
Okay. So we're gonna take this x over here and we're gonna replace it with 5. Okay. Replace it with the number 5. But I can't just do it over here. That means everywhere where I see an x, I'm going to replace it with
5.
5.
So that
Good.
means
So I'm going to go the
5
function where x
plus 1.
Good. So it's going to give me 2 times, you know that 2x is the same as 2 times x, yeah?
Yes, ma'am. Yes, ma'am.
Good. So I'm going to get 2 times 5 plus 1. And what's that going to give me? What's 2 times 5?
2 times 5 is 10.
Plus 1?
Is 11.
11. Good. So when I write this as an ordered pair or as a coordinate shaded, I'm going to say, which number did I choose for x? What was the number I chose for x?
5.
5. And when I chose x as my answer, what did my formula give me?
11.
11. Do you see how I'm writing? So I chose
Yes,
x to be 5. And the number that I got out, my y value, was
11. Y is 11.
Is that making sense?
Yes, ma'am. That makes sense. That makes sense.
Good. Now don't go away. Don't go away. Right.
Okay.
We're going to go onto the line over here, onto our Cartesian plane. Okay. If my x value is 5, I'm going to count onto the positive side. 1, 2, 3, 4, 5. This is 5. Yes?
Yes, ma'am.
This is the 0.5. Now, my y value needs to go on this straight line, this vertical line called 1. Okay,
Yes, ma'am.
so we're going to count up 11 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. Okay, it's going to be somewhere in between. Now, what I need to do, Shaden, is I need to put this one together, extend it this way, and I need to bring my 5 up. This is my 11 over here, and I'm going to bring 5 up. Yeah, this point where they cross each other, right there.
Yes, ma'am.
We call that point 5, semicolon 11.
11. Yes.
Okay. That's the idea behind a linear. Are you with me here?
Okay. Yes, ma'am. It's making sense. Making sense.
Okay. Excellent. Excellent. We're going to try another example.
Okay, ma'am.
Excellent. Now, what we want to do, guys, what we're actually trying to do here, guys, is not to make up 6 million examples. That's not the point of this. What we actually really need, guys, is just 2 examples. We only need 2 examples. Okay, we need 2. So I'm going to use these 2 points. I'm going to use the point where x is equal to 0, because when we put 0 in, 1 comes out. Okay, so when x is 0, when we choose x to be 0, then y is 1. And when we choose x to be 1, y is 3. Okay. So we're going to go back onto this. I knew I would do that. Okay. We're going to look for the point 0 for x. This is the point 0 for x. And where x is 0, y is equal to 3. So here's the point 0 and 3. And then if I go look for the point 1, oh, 0 and 1. Let me look at me lying. The point is 0 and 1. Okay. So I've got 0 and 1. There's my first point, 0 and 1. Now, when x is equal to 1, I'm going to go to this side where x is, there's 1. And I'm going to go up to where y is equal to 3. 1, 2, 3. There's 3. And I'm going to make them meet. Okay, so this one is going to go up. And that one's going to go. Then what I'm going to do is I'm going to pick up a ruler and I'm going to put one of them on the point 0, 1. I'm going to put part of my ruler on the point 0, 1. And the other part of my ruler on 1, 3. 1, 3. Okay. And then I'm just going to do this. I'm going to draw a straight line right through all of them. Like that. Okay. And that's going to give us that straight line that we are hoping for, because this is a linear function. Okay, that's okay, Makawanolo. We're going to look at another example. No worries, Mamelo. Okay, let's look at sketching graphs. Okay, we're going to scrap the dual intercept method for now because we still need to understand the Cartesian plane. Okay, let's do this one over here. Now we've got y is equal to 2x plus 3. Now I'm going to ask you guys for this one. If x is equal to 0, then y is equal to, what is y equal to? Now that means you need to go over here and replace x with 0. What would my y value then be? Good stuff. Good stuff. Good. It's going to equal to 3. Remember, guys, we only need 2 points. We only need 2 points. So if x is equal to 1, then y is equal to what? Then y is equal to? Okay, Nkechi, what is 2 times 0 plus 3? What is 2 times 0 plus 3? That's it. Do you see where we got that? Because we replaced x with 0. We replaced x with 0. Now I want you to do the same thing, but instead of replacing x with 0, I want you to replace x with 1. What am I going to get? 2 times 1 plus 3 will give us 5. Okay. Cool. So we're just going to replace it wherever we see it. Good. Now, guys, we only need these 2 points. I know that my x value was 0 and my y value was 3. And over here, I know that my x value was 1 and my y value was 5. Okay. So this is my x coordinate. This is my x axis, and this is my y axis. Now, guys, remember, this is the positive side. And this is the negative side. For my y value, this is the positive side, and down here is the negative side of y. Here in the middle, this is our origin, the right in the middle where everything is 0. Okay. So now, if I go to the point 0 for x is 0 over here, I need to go 2, 3 for y. So I'm going to count up. 1, 2, 3. So my first point is going to be 0 and 3. Here we go, 0 and 3. Now, if I go to my x-axis and I go to the point 1, this is my x-axis. If I go to the point 1, tell me in the chat, guys, where do I need to go for my y value? If my x value is 1, what is my y value going to be? Five, how many? Up how many? 5, good. I'm going to go up to 5. Right, so this is the point 5 over here, and this is the point 1 over here. But these two things aren't isolated. They need to meet. Okay, they need to meet. So we need to go this way and then bring this one up so that they can meet at this point over here. The point where they meet, this is the point called 1 and 5. And then what you're going to do, guys, is you're going to pick up your ruler, put one of the parts of your ruler on 0, 3, and you're going to put your other part of the ruler on 1, 5, and you're going to draw a straight line. And this is the graph of y is equal to 2x plus 3. Or we can even replace y with f of x is equal to 2x plus 3. Y and f of x are kind of the same thing. Y and f of x, same thing. They both mean output. Okay, give me a thumbs up if we're understanding this part. Excellent, excellent. Okay, Makoronole, let's try another one. Do you want to put your hand up for me? Let's put our hand up, put your hand up for me, and then we'll work through one together. Okay. Hi, Romulemo. Do you want to unmute for me, my sweetie?
Hi, ma'am.
Hello, my sweetie. What's up?
I'm good, and you?
I'm good, thank you. How can I help?
I'm fine, but like I just want to ask some question, like
Yes,
to give you answers positively.
Okay, go for it.
Number B.
B, absolutely. All right, we're going to choose 2 values. Okay, Romulimo. Let's choose when x is equal to 1 and when x is equal to -1. Okay.
Okay.
All right, can you do that for me?
Okay.
Good. So if we replace x with 1, what are we going to get?
5 times 1 minus 4, which is gonna give us 1.
1, good, because 5 times 1 is 5 minus 4 is 1. Good. Now I want you to do the other one. I want you to go 5 times, what's our x value now?
-1.
Good, 5 times -1. All right, so what is 5 times -1?
-5.
Minus 4.
Okay. -5 minus 4. Negative minus negatives give us positive, right?
No, that's when we're multiplying. At the moment, we're not multiplying, we're minusing.
Oh,
Okay.
we add. Okay, the answer goes to -9.
Good, the answer is going to be -9. All right, so my 2 coordinates are going to be 1 and 1, and what's the other coordinate going to be?
-9, -1, -9.
That's it, good. I'm going to go -1, semicolon, -9. Excellent. All right, so let's plot this on the graph, my sweetie. Let's do it. Okay.
I mean, for the scale,
Yes.
is it fine if I use like odd numbers like -1, -3, -5, and so on?
100%. You won't even make a difference, my sweetie. You do what you got to do. Okay, as long as the points that you're using are numbered. Okay, so you need to give it, you need to give them the correct coordinate. All right, so we said over here, if our x value is 1, our y value needs to be
1.
1, good. So we're going to go to 1 and 1, and then we're going to join them together. You agree? This is the
Yes.
point 1 and 1, correct?
Yeah.
Okay, tell me, which side of the 0 is my -1 going to be, on the right or on the left?
Could you please repeat?
Okay, I want x -1, x as -1. Is it going to be on this side or on the left-hand side? Is it on the right-hand side or on the left?
Left.
Good, it's on the left. Good. So this is going to be -1 over here. Right, now we need to represent -9. Is it going to be at the top or at the bottom?
Bottom.
Good, at the bottom. Okay, we'll just put it somewhere down here. Okay, it doesn't really matter where it's sitting as long as we label it correctly. Are you with me?
Okay. Yes, ma'am.
Good. So now these two things need to meet. Bring that one down also. Okay,
Yeah.
What am I going to name this point here, Umulemo?
Ma'am, actually it's Swela. Negative.
Oh, okay. So it's just that your name says Homolemo. So I was assuming it's Homolemo. But Swala, now I'm thinking you're a new person, but that time you've been here the whole time. Swala. Okay. We'll change your name for you, don't stress. Okay, so Swala, tell me, what is this point over here going to be?
It's gonna be -1, -9.
That's it. Beautiful. What's the last thing I need to do now, Swela? Now that I've got my 2 points, what do I need to do?
You have to connect them.
Good. So I'm just going to take a ruler and I'm going to
Connect them. Then graph of f of x, whereby f of x equals to 5x minus 4.
Beautiful. I couldn't have said it better myself. Just mwah. Excellent work. Very well done, my sweetie. You're so proud. So proud. Excellent. Excellent. I know the line is so straight. I used a ruler. I used a ruler. Guys, please use rulers. Okay. Somebody named iPhone says, how did we get -9? Remember, we replaced x with -1. So we're going to get 5 times -1 minus 4. If you punch this into your calculator, tell us what it gives you. Okay. Oh, that's okay, Kariso. You don't actually have to say, you don't have to say, Kariso. If you're feeling sick, my sweetie, we are recording. Okay, so you can come back to the video, to the video a little bit later. Okay, go take care of yourself. Hope you feel better soon. Okay. Tato, oh, Tato, where did you go? Hi, Timberlake. Hi, Timber. Sorry.
Hello.
Hello, how are you doing?
I'm good, ma'am. I would like to ask, because now the x, where do we get the x value? Because I get how to do the whole thing, but now where do we get the x?
You choose it. You get to choose x. Okay.
So
you
in the
whatever
exam,
x you want. In the exam, we just pick any number. You just pick any 2 numbers. So you can pick x is 1 and x is -3 or whatever. As long as those 2 numbers gives you 2 coordinates, then you can just join the 2 coordinates with a ruler. Okay, so you get to choose them. Okay, Temba, don't go away. Let's do C together before you go away. I want you to choose 2 values for us. Choose 2 values for x. X is
3 and 7.
7. All right, let's substitute. Right, if x is equal to 3, what will y equal to?
It will equal to what again?
3 minus 3 will give us?
Oh, 0.
0, good. 3 minus 3 will give us 0. Okay, what about if x is equal to 7? Then I'm going to get 7 minus 3, which will give us?
4.
4, good. Now I have 2 coordinates. I've got the coordinate where x is equal to 3 and y is equal to 0, and where x is equal to 7 and y is equal to 4. We're going to plot this. Okay, let's plot it together. Right, so we're going to go to where x is 3. X is 3, let's extend a little bit. 1, 2, 3. here. X is 3 over here, where x is 3, y will equal 0. So do you agree with me that the point is sitting on the x-axis at 3? Yeah?
Yes.
3, 0. Good, because 0 is on that line. 0 is here for y. All right, so we now need to go to where y is equal to 7. I mean, x is equal to 7. So I'm going to go 3, 4, 5, 6, 7. There's 7. Temba, when x is equal to 7, what is y equal to?
4.
Good, it's equal to 4. So we're going to climb up this side. 1, 2, 3, 4. That's where it is. And there's x is equal to 7 and y is equal to 4. Then we're going to have them meet like that. Yes?
Yes.
So there's the point 7 and 4. What's the last thing I have to do?
Join the dots.
Join the dots. Just take a ruler and join the dots. That's all. Just like that. Just make sure that your graph cuts both lines, the x and the y line. Okay. Look at how beautifully you did that. There's your line. You choose whatever values you want, and then you just draw them through.
All right. Thank you.
Okay. You're very welcome. That's it. All right. I see Shaden saying, ma'am, can I do the last one? Absolutely. You need to put your hand up so that we can do it before we get started. All right, Shaden, where are you?
I'm here, ma'am. I'm here.
Excellent. All right. I want you to pick 2 values for x for question D.
Ma'am, can I do 5 and 10? It's 5 and 10.
Good.
Fine.
All right. So we're going to choose x is equal to 5 and x is equal to 10. All right. If x is equal to 5, what will y be equal to?
15.
15, yes. 3 times 5 will give us 15. 3 times 5 is 15. Okay. Then if x is equal to 10, what will we get? Y will be equal to?
30.
30. Excellent. Now give me my 2 coordinates, Shaden. I'm going to open brackets. What's my x coordinate over here?
5.
And
semicolon 15. Y is 15.
Good. And then the next one, open brackets.
Will be 10 and y will be 30.
Excellent. Beautiful. Now, this is very messy, so I'm going to try and clean it up. Okay. Give me a second while I try and clean this whole thing up. Okay. So we're going to plot all of these points on our Cartesian plane. Okay. Let me get another Cartesian plane going here. All right. I'll move it just now. There we go. All right. Cartesian plane back. All right. So we agree that our x is 5, so we're going to go to the positive x side. Remember, this is 0, and this is the negative x side. This is the negative. Good. So we're going to go 1, 2, 3, 4, 5. There's x is 5. When x is 5, what is y equal to?
15.
Good. I'm just going to put a point here, and I'm going to name it 15. Otherwise, we're going to run out of space. Okay. What do I need to do to find the coordinate? What do I need to do with this 5 and this 15?
You need to make dots, madam, to the and up.
Good, yes, to the right and then up. And exactly where they meet, that's the coordinate we're looking for. That is 5, 50. Good,
Okay.
0.5. Good. All right, what was our other point again?
10 and 30.
Good, 10 and 30. So we're going to go 1, 5, 6, 7, 8, 9, 10. There is 10. And I'm going to make a random point here at 30. Okay,
Yes.
then we're going to go up.
And to the left.
Right, to the right, to the left.
Oh, sorry.
It's inverted on this side, so it's going to look a little weird. All right, so 10 and
30.
30. What's your last step?
You have to make use your ruler and make the line thingamajig.
Absolutely. Draw a line right through the 2 points. Okay. And look at that, Shaden. You have just drawn us the function of y is equal to 3x. Congratulations. Ta-da! Then we call this graph. We say this is the graph of f of x is equal to, what is f of x equal to?
Is it 5?
It's this point here, this one. F of x is equal to
30, 10, 10, 10 and 30.
Just 3x. Okay, that's all. So we're just going to take the name, we're going to name it what it is we've got down here. Okay,
So
we're going to name it what we have down here,
f of
but we just replace the y with f of x. Okay.
Okay. Thank you, ma'am.
Okay. Are you understanding what's happened now? Are we cool?
Yes, we cool now.
Excellent. Awesome. All right. Somebody said, ma'am, what's the difference between this one and the one with the squiggly line? I'm not sure which one with the squiggly line, which one that one is. You're going to have to give me a name so that you can figure that out. Takane says, so we pick any numbers lower than 9 and they don't give as a number. Well, they will. Okay, so what we normally do, Takane, is we will pick a positive number and a negative number so that it gives us one number on this side and one number on the other side. And in that way, we can then draw the line. Okay. Yes, Atlehan, you always get to choose the value of x. Now, I see Tinyugo saying, may I please solve E? So what I'm going to ask you guys to do is I'm going to ask you to take a screenshot of this, because we are out of time, unfortunately. I'm going to ask Teacher Nelly to run a very special poll for me today. It's called June exam subjects. Can I ask you to run that poll for me, please, Teacher Nelly? Oh, Palisa, thank you. Palisa's like, before she forgets, happy Mother's Day to Teacher Coco and Teacher Nelly. That would be wonderful.
Thank you.
If Teacher Nelly and I were moms, but unfortunately we're not moms.
We are.
Okay, I mean, I'll be an honorary mom. I'll be a teacher mom. Okay, so I'll take it. Thank you very much, teacher. Thank you very much, Palisa.
I wanted to say something about like that you always be given the x values. But if sometimes they ask you to use the intercept like method?
Yes, so we're going to learn about the intercept method in the next lesson, Teacher Nels, because we just didn't quite get to it today. Teacher Nelly, I need to have the poll ran for me as well. So once we're done with this one, can I please ask you to run the June exams one? And Palisa and Shaden, I agree with you guys. Yes, you are my children. So happy Mother's Day to me. Thank you very much, everyone. Stevie, what's up, sweetie? I see your hand is still up. Yes, Lisha, there will be. Hi, hello, my sweetie. What's up?
My question was, someone asked about if we give the value of x. So my question was, in the exam, they don't give us if x equals 2. Just choose like a random number.
That's it. So the question will normally say something like, draw the function of, draw the graph of, and then they will either give you y is equal to minus 2x plus 1, or they'll say f of x is equal to 3x minus 2. Okay, so in this case, you see that they haven't given you any values. Okay, they don't give you any values. So you get to pick those two values and then you draw them the graph. Okay, sometimes they will give you specific values that they want you to use, but we've just learned how to substitute, haven't we, Didi?
Yes, ma'am.
We just learned, if they give you the value 1, you just take wherever x is and sub it in with 1. Okay.
Thank you.
All right, you're very welcome, my sweetie. Anotita, I'm so sorry, my sweetie. I'll be, okay. I will make sure that I ask you to answer a question for me next. Okay. G of x is the same as f of x. It's also y. Okay, it's also y. Tato.
Hi, ma'am. I just wanted to ask if, like, on Wednesday we're going to do the turning point.
Yes, so on Wednesday, we are going to start looking at the parabola, and the parabola is a turning point. Okay, that's the one we're going to do on Wednesday. So I'm going to expect to see your hand going up and down because you're going to be answering all those questions for me. Okay.
Thank you.
You're very welcome, my sweetie. Yes, Anatida, you can absolutely ask a question. You can put your hand up for me. Yes, Anatida. No, not at all, Shaden. Don't stress. Hi, Anatida. What's up?
I just have a question. So the questions that you told us to screenshot it, do we have to put our own numbers into those?
And then the other one.
Yes. Okay. So this one, right? You get to choose your values for X. But remember, for me to draw the graph, I only need 2 values because I just need them to put my ruler together. Okay. So choose any 2 values and then go draw the graph for me. Okay.
Okay.
Excellent. Thanks so much.